Pendulums. This is my introduction. This demonstration will show you how the mass of two pendulums with the same length does not change anything. However, if we change the length of the two pendulums, the periods will change. This is important because a long pendulum has a longer period than a shorter one. That is, it swings back and forth more slowly or less frequently than a shorter pendulum. We can use this for a real-life example. When walking, we allow our legs to swing with the help of gravity like a pendulum. In the same way that a long pendulum has a greater period, a person with long legs tends to walk with a slower stride than a person with short legs. This is most noticeable in long-legged animals such as giraffes, horses, and ostriches, which run with a slower gait than do short-legged animals such as dachshunds, hamsters, and mice. So how are we going to demonstrate this? We will need some string and two masses. We are going to create a simple pendulum and then show a demonstration online and in person. To create a simple pendulum, you will need to suspend a stone at the end of a string. There is an example on the next slide. Galileo discovered that, regardless of mass, two pendulums of the same length will have the same period, or the time of one back and forth swing. So for this demonstration, we have both pendulums at a length of 2 meters. However, the first pendulum has a mass of 1 kilogram, and the second pendulum has a mass of 0.5 kilograms. Now if I press play, these two pendulums will have the same period or the same speed. Now if I change the mass of the second one to 0.1 kilogram and the mass of the first one to 2.1 kilograms, they will still swing at the same speed. Now for my second demonstration, I have the first pendulum set at 2 meters and 2 kilograms, and my second pendulum is set at a length of 1.5 meters and a mass of 0.5 kilograms. Now when I press play, you will notice that the second one has a faster period than the first one. This is because I changed the length of the strings. But why? Because the exact relationship for the period t of a simple pendulum is t equals 2 pi times the square root of L divided by g, where L is the length of the pendulum and g is the acceleration of gravity. And because g is constant at 9.8 meters per second squared, the only variable that changes t is the length of the string. Mass is not included in the equation. So in conclusion, we know that mass does not affect the period of a pendulum, and that the only factor to change it is the length of the string. In figure 25.2, we see a pendulum swinging back and forth on a conveyor belt. When the conveyor belt moves constantly to the right, we can see that a sine curve is formed. This sine curve is also the shape of a wave. This is my introduction. In these demonstrations, I will be showing you the two different types of waves and the differences between the two. Now there are two types of waves. One is called a transverse wave and one is a longitudinal wave. So what is a transverse wave? Whenever the motion of the medium, or the rope, is at a right angle to the direction in which a wave travels, the wave is a transverse wave. So what does that mean? That means that when the wave is traveling this way, and your hand is moving up and down, when you connect the two, your hand is moving at a 90-degree angle compared to the motion of the wave. Here is an example of a transverse wave. Now, in this example I will be showing you, I am doing it in person. However, it is kind of hard to tell, but as I am moving my hand, I am moving it at a right angle compared to which way the wave is moving. Not all waves are transverse. Sometimes the particles of the median move back and forth in the same direction in which the wave travels. The particles move along the direction of the wave rather than at right angles to it. This kind of wave is called a longitudinal wave. Both transverse and longitudinal waves can be demonstrated with a loosely coiled spring or slinky. So, for a longitudinal wave, your hand is moving this direction, and also the wave is moving in this direction. So, the movement of your hand to the wave is parallel. Now, compared to a transverse wave, a longitudinal wave is when you move your hand in the same direction as the wave. So for a transverse, going up and down. Longitudinal, you're going towards or away as the direction of the wave. So here I am doing a longitudinal wave. My hand is moving in the same direction as the wave, and you can see that the waves go straight instead of up and down like a transverse wave. So what happens when two waves collide? When two waves collide, they form an interference pattern. The effects of the interference pattern may increase, decrease, or neutralize the effects of the wave. When the crest of one wave overlaps the crest of another, their individual effects add together. The result is a wave of increased amplitude. This is called a constructive interference, or reinforcement. When the crest of one wave overlaps the trough of another, their individual effects are reduced. This is called destructive interference, or cancellation. Wave interference is easiest to see in the water. The right figure shows the interference pattern made when two vibrating objects touch the surface of the water. The gray spokes are regions where crests of one wave overlap the troughs of another to produce regions of zero amplitude. At points along these regions, the waves from the two objects arrive out of step. We say that they are out of phase with one another. In the first figure, we see that the dark and light striped regions are where the crests of one wave overlap the crests of another, and the troughs overlap as well. In these regions, the two waves arrive in step, or they are in phase with each other. So what does that mean? That means the figure on the right is experiencing cancellation, while the figure on the left is experiencing reinforcement. Now you may be asking, why is this important? Interference is important because it is a characteristic of all wave motion, whether the waves are water waves, sound waves, or light waves. So, in conclusion, we learned that the mass of a pendulum of the same length does not change the period of the pendulum. We also learned that there are two different types of waves. One is called a transverse wave, and one is called a longitudinal wave. Lastly, we learned that there are two different types of interference, constructive and destructive interference. Alright, so let's do a quick check. Which wave occurs when your hand moves in the same direction as the wave? Transverse or longitudinal? If you said longitudinal, you're right. Alright, quick check number 2. Which variable changes period? A, length, B, gravity, or C, mass? The answer is A. Number 3. What type of interference is caused when the crest of one wave overlaps with the trough of another? A, constructive, or B, destructive? Correct answer is B. Number 4. When the crests of one wave overlap with the crests of another, they are A, in phase, B, out of phase. A, in phase. Number 5. Did you learn something new today? I hope you did. Thanks for watching.